Yes.
Hello. Am I audible?
Could you share your screen and camera?
Oh, okay.
So Itbaan will present multitask learning for visually grounded in gastrointestinal VQA.
Is the screen available?
Yeah.
Okay. So hi, my name is Itbaan, and I'm joined with my co-authors, and we are from Institute of Business Administration, Karachi, Pakistan. So I will be presenting this. So I will be presenting our paper, multitask learning for visually grounded reasoning in gastrointestinal VQA. Okay, so our main takeaway message would be that instead of trying to make different architectures or complex architectures or fusion techniques, we can leverage pre-trained models. Like in our case, we use Lawrence to model, and we can develop different augmented data sets and auxiliary tasks to use the pre-trained knowledge of these models and for the domain-specific task. In this case, it was gastrointestinal imaging. So our motivation comes from our experiment. So we did some zero-shot experiment on Florence model for image captioning. So here you can see the model is wrongly classifying the image as personal changes area, but it has a good understanding of what the image looks like. For example, here it says the picture has pinkish red color. It has surrounded by a thin white line. So you can see the model already understand what the image looks like. So our idea was, why not connect these visual features to correct medical answers in the VQX1 dataset. Another finding was that when we trained just on VQA training, we noticed the model already started to have some understanding of the image. So in this case, the model was correctly identify a polyp, and so we decided that we can further improve this reasoning by creating another augmented data set that can map these marks to correct regions to correct answers in the VQX1 data set. So our approach was to create augmented data sets and to join multitask training for Florence model. So the first model we created was the explanation data set, and our goal was to enhance the answer with color, location, and visual appearance. So this is the one example of a sample in our augmented data set. So this is the pipeline. So here we get an image, and we get a question and answer for the image. Then we get some additional grounded data from the QSL VQA data set. So you can see we have this size, color, and other details. And then we generate more visual descriptions from a JAMA 27B model. And then we again synthesize all this information to another JAMA 27B model via fusion processing. And then we will get this well-structured answer that not only has the correct single polyp answer, but also has other details like its type, size, and visual appearance. Similarly, we created around 3.3K samples. Okay, so another data set that we created was the text to relevant region data set. In this data set, our goal was to connect the medical answers to the correct region of interest. So our method was, so we used, so for polyps and instruments, we already have quasi-specific data set. And in this, so we use the marks from these data sets and connect them to the QSA-VQX1 answers. And for some images, many images, there was no marks available. So we created some pseudo marks using some textual prompts from clip segmentation model. And then we connected those segmentations to relevant answers in the explained data set. So we created 4.3K samples for this augmented data set. And then we train all these data sets in a multitasking framework in a Florence 2-based model. So we did some ablation studies, and these ablation studies was on the validation state of 80-20, and we avoided any image overlap. So in this study, you can notice that when we are training just on the VQA training and increasing the parameters, our blue scores are increasing, but our segmentation scores, the visual understanding of the image was actually degrading. So this was some indication that when you are increasing parameters, the model was overfitting to linguistical cues, but it was, by doing so, it was losing the visual alignment to those answers. But when we did the multitask framework, our blue score also increased, and our the visual alignment was also maintained and improved as we increased the parameters. So these were the scores that we got from the private test. Okay, see, are some examples. So this is the example of just doing VQA training. Here the model was not able to identify the correct size of the polyp, and the segmentation was correct, but it was not precise. And here the model also correctly identified the location of the landmark, but it was the segmentation doesn't shows any reasoning. After doing multitask training, the model was able to correctly identify the size, the segmentation was precise, and we had a good explanation of the answer. And here, this is an example of pseudo mark. Also, it might not be the perfect mark, but it was enough to give the correct region of interest to the answer. And here you can also see that in the predicted answer, it is not mentioned what landmark it is, but in explanation, it was able to pick the Z-line landmark and also the correct location of the landmark. So there were also some limitations. Subtask 2 scores, we had a weak faithfulness score and a clinical relevance and completeness scores. Our hypothesis is that the reason behind is that our reliance on synthetic text from the JAMA model, and there is some many hallucination explanation in our inference. And there was also a lack of negative samples in our augmented data because most of our data has the answer, yes, there's abnormality, yes, there's a landmark. So when there was a case when the abnormality does not exist, the model was not able to identify or give any explanation why it does not exist. And pseudomarks were not perfect because it was just approximation. So here's some example of some contradictory output. So the explanation contains first the correct size, then it goes on to say another size which just contradicts what it said before. Our future outlook, so we can actually improve this synthetic data generation by using expert annotations and diverse models. And we can also define our segmentation marks by using the current pseudomarks and prompting another powerful model like segment analytic model to create more refined marks. Our training strategy can be also improved by, because in here the training was on the location tokens of Florence 2. So the segmentation that Florence 2 generated were the location tokens, not so we can also leverage, for example, we can get the features of the Florence 2 models and then train a separate segmentation pair on it. And understanding model behavior, we can also apply techniques. Another technique to further any text. Thank you. Any questions?
Are there any questions?
Thanks a lot. That was a really nice approach. I have a question. If you go back to the slide before the summary, slide 9, I think.
Yeah, here.
So for me, it looks like it doesn't really understand that the polyp and the Paris classification is kind of about the same object because it does the size different. What do you think about that?
Yeah, that's what I was saying, that this problem, our framework has this limitation. because here the prediction was right, then the explanation just hallucinate to another explanation and just skip another side of the polyp.
Yeah, I don't think that's a problem with your framework. I think in general it's interesting to think about that because it looks like it doesn't really connect the two to the same base object. If the polyp is kind of the ground object, and it's just a different way to look at the polyp. But if it doesn't match that the size would be the same or has to be the same because it's the same polyp, then it kind of has a misunderstanding there, I think.
Yeah, so you are saying the alignment of the visual segmentation and the explanation is not correct?
I think it's maybe a core problem in the LLM. I don't know.
Yeah, it could be because the segmentation also makes the instrument also segmented here. Or the correct segmentation should be just the polyp here.
I have a question. Sorry, did I interrupt anyone?
No.
Okay, Itbaan, so how did you come up with that explanation? Did you append multiple output from LLMs there? How did you get that? Because it's not one.
The explanation?
Yeah.
So we get it from the following two model. So we train the model to generate these explanations by using our augmented data set. We train the model, and in the inference part, the model just generated those explanations. So, we use the special token in the Florence 2. We train it on MediaEval explain token. Yeah. So whenever it sees that token and the question, it will generate the answer with an explanation.
Yeah, so I read your paper. It was one shot generated or it was concatenated from multiple generations. I quite didn't get that thing. So was the whole explanation paragraph generated in one shot from that?
Yeah, it was in one shot.
Okay. Yeah, I think if you incorporate this self-probing thing like in the previous presentation, so maybe you can generate multiple explanations there and try to take an average or do something, summarize that thing. So maybe it can solve this kind of differences because you would need one more layer that has been seen in recent approaches. They ask multiple questions and they probe what model things and they summarize the answers that the model gives. So this new added complexity there might resolve this kind of problem. But it's impressive that you managed to add segmentation and come up with explanation from there. And you are only the team to use the visual signal. So I really like that you spend your time doing this.
Thank you.
All right. Thank you, Itbaan. I think we can wrap up.
Thank you.
Then the next speaker is Krishna Tiwari. Krishna, are you here? Cannot see you in Zoom. I know there is a video.
There is a video, yeah.
But I suppose we will play it at the end and give Krishna another chance to show up.
Yes.
So then the next speaker would be Devesh Jha. Are you here, Devesh?
I can see participants from his team there. So anybody who is going to present, he can come if Devesh isn't here.
Who still needs to present and is at Zoom or is a room here? I also have Seshan Khan that still needs to present later, and Sivasariraman E. None of these presenters are here. Maybe they assumed that they would present a bit later, although we are coming to the end of the session as well. Meentreat, are you, in the meanwhile, did you join? I suppose not. So perhaps we should play one of the videos.
I guess that's so. And then we just hope some of them come back.
Yeah, okay, let's do one bit.
So we have two videos available from the people missing. Should I take them in order? Yeah, okay, so.
Yes, to do the one from, I think the Vietnam one first, because it's latest.
Okay,
Yeah.
yeah. I think I should put some. Or,
Yeah,
Yes.
yeah, computer science, I guess, yeah,
hopefully
maybe so,
that's gonna be okay.